Quantum computing is not just about faster calculations, it's about redefining what a computer can do. This is an exciting trend moving from science to reality and set to transform entire industries. Welcome to WisdomTree's Fireside Chat. I'm Mubin Tahir, and here to decrypt quantum computing, I have Elvira Kurumshina and Blake Hyman. How are quantum computers different from classical computers? And from an investor's perspective, why does this matter and why should we be paying attention right now?
Mubin, let's start with a comparison of classical computers versus quantum computers. Classical computers are general purpose workhorses, and they run everything from spreadsheets to AI. However, there is certain types of problems that classical computers struggle with, and there are certain types of problems that they will never be able to tackle. And this is exactly where quantum computers can excel. And the reason for that is because they are using a different compute architecture. It's indeed a paradigm shift in how the information is being processed in a machine and how computations are being done. The first scientist, actually one of the most prominent scientists of the 20th century, Richard Feynman, who proposed the concept of a quantum computer, did so because he wanted to study quantum events. And he very quickly realized that to do that on a classical computer is almost impossible. And this is where his famous quote comes from. Nature isn't classical. And if you want to make a simulation of nature, you'd better make it quantum mechanical. This is why quantum computers might be better machines to handle some tasks that have this high degree of complexity that actually overwhelms classical machines. But the reason why investors are excited about the technology today is because we are seeing tangible progress in the field towards scalable systems in the future. And all this surge in quantum computing activities, the momentum in the private and the public space, and actually, the Nobel Prize that was awarded in 2025 in physics to 3 scientists who essentially laid the basis for quantum computing also confirms that the scientific community agrees that there is a path to scalable systems in the future. And for investors who are excited about the technology, who see the potential in it, today is a good time to start looking into it, into associated opportunities, and the way how this growth potential can be captured.
Another area that has major implications on the back of these quantum computing developments is an area we call post-quantum cryptography. Now, as we reach the point where quantum computers can scale and commercialize, there will be a day where a quantum computer can decrypt or break current public key encryption that secures all of our digital infrastructure as it sits today. Now, this is an existential risk for the data that sits at all the institutions and firms across the globe. So regulatory bodies are pushing firms to adopt this technology to protect that data. One of the forces counteracting this or playing at the other end is the hackers and those with malicious intentions, which are now saving and storing data as it comes today across the network that is using old encryption methods and saving it for later with the intentions of decrypting that with quantum computers at a later date. So the need to adopt post-quantum cryptography is something that needs to happen today, and firms are quickly moving to adopt this technology. So investors should be paying attention in the same way that companies are paying attention.
Let's maybe talk about use cases. Where will a quantum computer be used in different industries? Which industries might be impacted? What might be the use cases? What are you guys excited about?
So at the foundational level, the way we see quantum computing is really a revolutionary way to improve upon current methods of computing. So that means increasing the precision and speed at which computers can do calculations to solve problems. Some early examples of this, where we've seen some positive steps, are really in what we're seeing in hybrid computing, where we're seeing essentially high performance computing working alongside quantum computers to start to explore different types of use cases. So a recent development was the announcement of the progress made by HSBC, the bank, alongside IBM in exploring ways to better price bonds, to predict what prices OTC or over-the-counter transactions might get filled at. If they're better able to price these bonds and predict at what price they will be filled, they can lead to more efficient market making and market activities that the bank offers to their end clients. So this is one example where you could see quantum computing have a major impact. This is a meaningful uplift in terms of the capabilities that they have over peers. Another area that's interesting to pay attention to is healthcare, particularly as we've seen early indications of the efficiencies garnered in drug discovery. So IonQ, Amazon, NVIDIA, and AstraZeneca have worked together on a drug discovery workflow that has actually reduced the time for a simulation to run by 20 times. So when simulating molecular types of reactions, it's highly computational. So if we can narrow the timeline and reduce the cost from taking an idea to an actual drug that can be delivered to patients, that could have profound impacts for people.
From my side, I would like to discuss the opportunities that exist within the quantum computing ecosystem. So obviously right now, all the excitement is around quantum hardware, because essentially quantum hardware is where all the breakthroughs are happening right now. More powerful quantum machines that would be able to run various algorithms and to deliver outperformance versus classical machines. Software players already now are developing various algorithms, because this is possible despite the limitations of quantum hardware. It's possible to do that via quantum simulators and emulators. And we are already seeing how companies are moving to experiment with the technology. IBM is a leading company in quantum computing, and they have Qiskit platform, which is the platform exactly for quantum experimentation. So that platform already has around 600,000 registered users. Vanguard is another firm in financial services that reported experimenting with quantum computing for portfolio optimization. There are also investment opportunities that exist for post-quantum cryptography providers, and also in adjacent field, quantum networking and communications, which actually uses quantum hardware, is a bit more mature than quantum computing itself, but is also a foundational technology within broader quantum stack and is the foundation for the future quantum internet, for potential distributed quantum computing. We also shouldn't forget all the enabling players, companies who are providing components, materials, systems, tools that go into building quantum computers and associated growth opportunities. And at the same time, these companies, they don't solely focus on quantum computing. In fact, quantum computing at the moment might be some part of their business focus, and the major focus lies actually in other megatrends such as AI. So they get to benefit also from the synergistic demand.
How do you build an investment strategy in this space?
So we assess companies based on where they sit within the ecosystem and whether or not they will be accruing value in the quantum computing ecosystem as the technology continues to scale and to mature over time. So in the early days, we've seen a lot of focus on the hardware side of things, particularly in terms of the qubit technology, but that's been continuing to advance to enable quantum computers to come into existence, at least at the commercial scale. But there's other areas within the software space where essentially we need to remember that new software needs to be deployed to run on quantum computers. So this will be a whole new ecosystem that will evolve over time. And then we also have many of the enabling players to be thinking about, as well as these more somewhat auxiliary type of interesting exposures that are involved in, say, quantum networking, the security side of things with post-quantum cryptography. But the holistic approach here is to capture that entire ecosystem, but prioritize allocations and focus based on the areas that are accruing the most value and have the most impact, particularly as this technology continues to grow and mature over time.
And to understand which companies are best positioned within the ecosystem and that are most directly involved in quantum computing, We have partnered with Classic, and what Classic does, they are providing an operating system that can be integrated with any type of quantum hardware. That allows them to partner with so many companies across the entire ecosystem, also to get insights into various companies and different developments and trends that are shaping the industry. Quantum computing will mature in waves. This is why we had to develop a framework that would allow us to select companies that are most directly involved in quantum computing and that are also key to further progress in the space. And our relevancy framework allows to do exactly that. So we use relevancy score to rank the companies from high, medium to low based on the significance of their quantum computing activities. In the next step, we also classify companies into pure and diversified players. And we use both relevancy and purity in the weighting stage to tilt the final exposure towards most relevant and meaningfully pure companies. And the end result is a diversified exposure across the entire quantum computing ecosystem, aimed at delivering growth across the technology's maturity curve.
That was quantum computing. Very interesting. Thank you.